In this video, I will show you how to find the area of a triangle using matrices if you're given the vertices. So it really boils down to this formula right here. If you have three vertices of a triangle, and they are x1, y1, x2, y2, x3, y3, you can make a matrix in this way where the top row includes your first vertex and then a 1, and then your second row is your next vertex, x and y, and then a 1, and the bottom row is your third vertex and then a 1. If you make a matrix in that way, if you take the determinant of that matrix and divide by 2, you're going to get the area of the triangle. Now, I have absolute value symbols around it because sometimes you're going to get a positive answer, sometimes you're going to get a negative answer. But of course, area is always positive. So basically, no matter what you get once you do the determinant, consider it to be a positive area. Let's do problem number 1, for example. So for problem number 1, we are given these three vertices. So I can set up my matrix like this. All right, I'll start here with the point 1, 6. So because of the 1, 6, I'm going to have a 1 and a 6. You know what? I think I'll just go around and around. So my next vertex is 6, 4, so I'm going to have a 6 and a 4. And then my last vertex is 2, 0, so I'm going to have a 2 and a 0. Now, I will have a third column that's full of 1s. 1, 1, 1. And that is how you set up your matrix. Now, if I find the determinant of this matrix, if I take half of that, I will have the area of my triangle. So how do I find the determinant of this matrix? I'm going to use the method that involves cofactors and minors. So I have to pick a row to use. I'm going to pick the bottom row because the calculations are easier if you have a 1 or a 0. So this has a 0 and a 1, so I like the bottom row. So this is how I'm going to find my determinant. Okay, so I'll just put, I'm going to call this matrix A. So I am calculating the determinant of matrix A. And using the bottom row, that's going to be 2 times, all right, that's called a cofactor. And then now comes the minor. The minor is going to be what I get if I were to cross out the row and column of this cofactor 2. If I cross out this row and this column, that leaves me with this minor determinant. Okay, that is 6, 1, 4, 1. That's the minor. All right, my next cofactor is 0. So I'm going to just put, now look, there's a sign pattern that I'm using here. For the bottom row, the sign pattern is positive, negative, positive. That means I keep the sign of the cofactor the same for the first number. The negative means I change the sign for the second number. And the plus means I keep the sign the same for the third number. So normally I would change signs here and I would say minus. But for 0, it didn't really matter anyway. Let's talk about the minor. Can I erase just the yellow? Okay, so I have the same row, and now I'm going to cancel out this column. That creates the minor of 1, 1, 6, 1. So 1, 1, 6, 1. That's my minor. All right, now it's time for the third and final cofactor, and I will not change the sign. So I will say plus cofactor 1 times, and then now I need the minor. So I'm going to try to erase just this yellow. Okay, so that creates the minor 1664. So 1664. By the way, if I were to do the middle row, the sign pattern would be negative, positive, negative, change it, keep it, change it. If I did the top row, the sign pattern would be plus, minus, plus again. Okay, so here's how I calculate the determinant. So all of these minors, I'm taking the determinant of each one. So I have the determinant of A is equal to 2 times this determinant. When you do the determinant of a 2 by 2 matrix, it's down diagonal minus up diagonal. So that's 6 minus 4. I'm multiplying here, 6 times 1 and 4 times 1. Now, right here with the 0, 0 times any matrix is going to just be 0. So that's gone. I'm not going to even bother writing it down. So I'm moving on to really this one over here. So I've got plus 1 times down diagonal minus up diagonal. So the down diagonal is 4, and the up diagonal is 36. All right? I'm multiplying 1 times 4 and 6 times 6. Okay, so that means the determinant of A is going to be 2 times 2 plus 1 times negative 32. All right, in other words, the determinant of matrix A is going to be 4 minus 32. So the determinant of matrix A is going to be negative 28. So that means that the area of the triangle is going to be half of positive 28, because area has to be positive. So the area is going to be 14. All right, so that's the answer to number 1. Now, I encourage you to pause the video and try to do problem number 2 by yourself, and then play the video and see how you did. I'm going to just assume that you've done that. I'm going to start way up high with the 0.7, comma 3. So when I set up my matrix, it's going to be like this. I will have 7, 3, 6, negative 1, 1, negative 3. I've just written down the vertices going around this triangle. Then, of course, the third column is just going to be 1, 1, 1, like you do. So this is going to be my matrix. I will call this matrix B. So if I want to find the area, the next thing I need to do is I need to calculate the determinant of matrix B. So I need to choose which row I want to use. It's best if there are 1s or 0s. So I'm going to use the bottom row again, just like I did on the last example, because I see it has 2 1s in it, and they're both positive. That helps a little bit. And the number negative 3 is pretty small. Now the sign pattern for the bottom row goes like this: positive, negative, positive. That means when I use these numbers as cofactors, the numbers in front of my minor determinants, the first one I keep the sign the same, the second one I change the sign, and the third one I keep the sign the same. So my first cofactor is the number 1. So I put the number 1, and then that will be multiplied by a minor determinant. Now the way I get the minor determinant is what's left after I cancel out the row and column of the cofactor that I'm using. So if I cross out row 3 and column 1, that leaves this minor determinant: 3, 1, negative 1, 1. So, and I keep the sign the same for the cofactor. So now I'm going to move on to the next cofactor, which is negative 3. Now, because of the sign pattern, this negative tells me I need to change the sign. So I'm actually going to put a +3 for the cofactor instead of -3. And now it is time for the minor determinant. And same row, but now I'm canceling out this column. So that leaves the minor 7, 1, 6, 1. So 7, 1, 6, 1. And now it's time for the third cofactor, which is 1. And I keep the sign the same because of the plus sign. So I do a cofactor of 1, and the minor determinant 7, 3, 6, -1. So 7, 3, 6, -1. And then I can go on and do my calculations. By the way, had I chosen the middle row, the sign pattern would have been change it, keep it, change it. If I had chosen the first row, the sign pattern would have been keep it, change it, keep it. So anyway, moving on, the determinant of B is going to be 1 times this minor determinant, the down diagonal minus the up diagonal. That's going to be 3 plus 1. Now I said down diagonal minus the up diagonal, but yet I'm putting a plus. That's because the up diagonal is -1, and minus a negative is a positive. So now I'm going to have 3 times down diagonal minus up diagonal. That's 7 minus 6. And then 1 times down diagonal, -7, I'm multiplying, minus the up diagonal, which is 18. All right, let's keep going. So the determinant of B is going to be 1 times 4 plus 3 times 1 plus 1 times -25. So that means that the determinant of my matrix B is going to be 4 plus 3 minus 25. So the determinant of B is going to be -18. All right, so therefore the area of the triangle is going to be half of this. It's going to be half of +18. No matter what, you take it as a positive because area has to be positive. So therefore the area is going to be 9. All right, so that's the area of the triangle in problem number 2.
Work, work, Angelica, work, work, Eliza and Peggy, the Schuyler sisters, Angelica, Peggy, Eliza, work. Daddy said to be home by sundown, Daddy doesn't need to know. Daddy said not to go downtown, like I said, free to go, but look around,